Welcome back. Let's finish up our discussion on section 2.8 on absolute value inequalities, this time by talking about an application. This is sort of an interesting one. The problem we're given here is that a piston rod for an automobile is 9 5/8 inches long with a tolerance of 1/32 of an inch. It says find the upper and lower limits of the length of the piston rod. Well, what does all that mean? This is sort of an interesting question. Well, for those of you unfamiliar with the setup of a typical car engine, this is a Chevy up here, we have a piston here circled in red. Piston goes up and down within the engine, and it is attached to a piston rod. That rod, as the piston goes up and down, changes the vertical motion into a circular motion along this crankshaft, and that's what actually moves the car along. Right? So a close-up picture of the piston and piston rod assembly is shown right here. Right? Now we're just interested in the piston rod. Well, here's a picture of a piston rod that I found on the internet, and it says that that length is 9 5/8 inch. But then it says with a tolerance of 1/32 of an inch. Well, a tolerance means that we don't have to be exactly 9 5/8 inches. We could be, give or take, a 1/32 of an inch off of the actual value. But the question would be, well, what does that actually mean? So let me give you a formula here that you can use to solve this kind of problem. Right? Let's say that we let x equal the actual piston length after we've applied the tolerance. All right, and well, of course, our length of the piston rod, at least the basic value, is given as 9 5/8 in the drawing specifications, right? But if I'm a machine shop, right, and these things are being made by hand or machine, right, that could change, right? It doesn't have to be an exact value. That's why they give us a tolerance. So we're going to let that be our 9 5/8 inches. And of course, our tolerance, I'll call that T. Right? So our tolerance is that 1/32 inch. Well, how do we use that? What is the actual value right here? Well, the application then can be found for our piston tolerance with this formula. The actual piston length minus the given length must be less than or equal to the tolerance value. So in other words, it can be anywhere within the values as long as it is less than or equal to whatever our tolerance value is. So what do we do with that? Well, we're going to rewrite this inequality. We need to do something first. I don't like dealing with mixed fractions. I know a lot of people do like dealing with mixed fractions, but well, maybe we can leave it that way. Let's try it. All right, so we've got the absolute value of x minus, and our given length is 9 5/8 of an inch in the drawing specifications. But we want to make sure that is less than or equal to whatever our tolerance value in this case. That's 1/32 of an inch. Well, we've seen this kind of inequality before, right? Remember the rule? That's right. The absolute value of ax plus b is less than or equal to c means that we set up a compound inequality. In this case, it's a double inequality. Negative 1/32 is less than or equal to x minus 9 5/8, less than or equal to positive 1/32, right? In fact, this kind of makes sense if you read the way that this is set up. We're looking at this being the difference between the actual length and the drawing length must be less than or equal to 1/32 of an inch off of the actual value we want. Right? So it could be a little bit longer, but up to about 1/32 of an inch off or less than. All right, so let's work this out. Well, this means we're going to have to add 9 5/8 to both sides of this inequality. So we're going to have to add 9 5/8 plus 9 5/8. Right? Well, now this requires us to do a little bit of fraction math right here. That's okay, we can handle it. If I say 9 and 5/8, what I was going to say up here is that 9 and 5/8 is really the same thing as saying 9 added to 5/8, right? So we actually are going to have right here, in this addition problem, 9 plus 5/8 plus 1/32. All right, so we need to get a common denominator between these last two. So that's going to be 9 plus, let's see, 8 has to be multiplied by 4 to give us 32. 4 times 5 is 20. We're going to be adding that to 1/32. Okay, so at our upper limit, we're going to find that x is less than or equal to 9 and 21/32 of an inch. How about on the other side? Well, similar deal. We're going to be taking 9 plus 5/8 minus 1/32. Well, we've already partially done the work right here. 5/8 is the same thing as 20/32. And we're taking away 1/32 of an inch, which is to say that our lower limit right here, let me get my move this over, give myself a little bit of room. 20 minus 1/32 is the same thing as 19/32. So in fact, we've got 9 and 19/32 as our solution right here. So our tolerance value would say that our upper and lower limits of the actual length of this piston rod should be between 9 and 19/32 of an inch and 9 and 21/32 of an inch. Right. Good luck with your own problems. We'll see you in class.